Here's Leetcode problem 2226, maximum candies allocated to K children. The problem gives us an array called candies, where each element represents a pile of candies. We can divide each pile into any number of subpiles, but we cannot merge two piles. We're also given K, the number of children. Our goal is to allocate the piles of candies so each child gets the same number of candies. Each child can get candies from only one pile, or its subpiles, and some candies might not be used. The question asks for the maximum number of candies each child can get. Let's walk through the examples to get a better understanding. Here's the Python code for solving this problem using binary search. We start by defining a helper function, can_allocate. This function takes the candies array, the number of children K, and a potential number of candies per child, mid, as input. It checks if it's possible to give each child mid candies. Inside, we count how many children can receive mid candies from each pile, and sum this count. If this sum is greater than or equal to K, we know allocation is possible, so the function returns true, otherwise it returns false. The main part of the function uses binary search. We initialize left to 1, the minimum possible candies per child, and right to the maximum number of candies in any pile. We keep track of the best answer found so far in the answer variable. The while loop continues as long as left is less than or equal to right. Inside the loop we calculate the middle value, mid. Then, we call can_allocate to see if we can give each child mid candies. If it's possible, we update the answer and shift our search to the right half by setting left equals mid plus 1 to see if we can allocate even more candies. If it's not possible, we search the left half by setting right equals mid plus 1. Finally, we return the answer, which holds the maximum number of candies each child can get. Let's break down the can_allocate helper function in more detail. The core of this function is the loop for candy in candies. In each iteration, candy represents the number of candies in the current pile. The line count plus equals candy/mid calculates how many children we can give mid candies to from this current pile, using integer division. For instance, if candy is 7 and mid is 2, then candy/mid is 3. This result is then added to our running total count. Finally, we check if count, the total number of children we can allocate to, is greater than or equal to K, the total number of children. Now let's focus on the binary search logic. We initialize left to 1 and right to the maximum value in the candies array. Answer is initialized to 0. The key here is the while loop. In each iteration, we calculate the middle value mid. We call can_allocate. Candies, K, mid. If it returns true, meaning we can allocate mid candies to each child, we update answer to mid. Critically, we then set left equals mid plus 1 to search for potentially larger allocations in the right half. If can_allocate returns false, we know mid is too large, so we set right equals mid 1 to search the left half. This process continues, narrowing the search range until left is greater than right, at which point we return the final answer. The time complexity is big O of n log m, where n is the length of the candies array, and m is the maximum value in the candies array. The log m factor comes from the binary search, which repeatedly halves the search space between 1 and the maximum candy value. The n factor comes from the can_allocate function, which iterates through the entire candies array in each call. The space complexity is big O of 1, meaning constant space. This is because we only use a few extra variables, left, right, mid, answer, count, and their number does not scale with the input size. That's it for this Leetcode problem. If you found this helpful, please like, subscribe and comment below with your ideas on problems you'd like to see covered in this series. You can also help me continue making these videos by donating at buymeaboba.com. The link is in the description.